Hi, my name is Matej Farkas, and in this course I would like to teach you how to create SQL queries using only graphical interfaces without the knowledge of SQL language. This works only with Microsoft SQL Server product. Many people think that the SQL database can be used or can be queried only by using SQL codes, and they don't try to query data. But that is not true. In this course, we will not learn how to write codes in SQL, and we will not introduce you into SQL language. We will use only graphical design tools to query data from a database. This method can be used if all data is on the same SQL server, so we cannot combine different data sources in one query. However, we can produce complex queries with the following solution. You will not be able to create all kinds of SQL queries, but you do 90% of the generic queries. This can be useful for business people, business analysts, or report designers, or anybody who wants to query data but don't want to learn SQL language. If you have ever used Microsoft Access Query Builder, then it's good for you because this method is very similar to that solution. But if you have never used Access before, don't worry, it's easy to learn building queries with the following tool. If you want to query data with this method, then you need only three things. First, you have to ask a read access to the reporting database from your database administrator. He or she will know what to do to give you the read permission. If necessary, show him or her this video. You may get a username and password pair to connect to the SQL database, but it's better for you to set your permission in the background by Windows authentication, and then you don't need to memorize any username or password because your current Windows login will automatically authenticate you when you want to connect to the reporting database. Second, you need the database name and server name or IP address. This should be provided by your database administrator after the read permission is given to you. In this example, the name of the database server is report-SQL, and the reporting database name is AdventureWorks 2014. This is a standard sample database, and it can be downloaded from Microsoft. So if you want to follow the course with exactly the same dataset, then you can download it from here. Your database administrator can help you to download and restore this database on the reporting server. Third, you have to download and install the SQL Server Management Studio. This is the tool to connect to SQL database for administrative or data query purposes. This is a free tool and can be downloaded from Microsoft by this link, or search for it on Google by typing Download SQL Server Management Studio. Maybe you don't have rights to install a software on your desktop or laptop. In this case, you have to ask your IT helpdesk or system administration team to install this tool for you. So when all three prerequisites are met, then you can start the work by opening SQL Server Management Studio on your computer. When this tool is started, you will get a server login screen. This is it. Now you need the name of the database server what your database administrator gave you. If your permission is set by your Windows login, then you can choose here Windows Authentication. In this case, your Windows login name is automatically set and you don't need a password. But if you got a username and password, then you have to choose SQL Authentication and provide username and password here. Now I use this option and fill these data. In this case, it is useful to save the login and password pair because this will make easier the login next time. Please note, this method should work not only by on-premise SQL Server, but cloud-based Azure database as well. After you log into the database server, an Object Explorer pane will be displayed. The database server name is on the top of the tree view. The SQL Server Management Studio is not just a query tool, but it's an official management tool for SQL Server, so you can see here many things and functions organized into different folders of the tree view. But you need only the databases folder now. Here you can browse your database in the databases folder of the tree view. In this case, our reporting database is AdventureWorks 2014. Okay, now let's see an example of a desired report in this database. The specification of the report is written in a couple of sentences. List all salespersons by summary of total sales in 2011 of products where the product name starts with HL mountain frame. A salesperson must be displayed even if he doesn't have any sales in that year. Finally, compare these restricted sales amount to the salesperson's total sales in 2011 based on order date. Here you can see a sample of desired report structure. We need to produce the dataset of this report. To get the result, you as an analyst need to know the database structure and the role of different tables. Okay, let's see what tables we need for this query. Sales.salesperson, of course. Person.person because of the full name and because salesperson doesn't contain the name of the person. Production.product because we need to filter on the name of the product. Sales.sales order header because of the order date. And sales.sales order detail because of filtering on products and the summary of sales. Okay, now let's go to SQL Server Management Studio and start designing this query. Remember, the first table is sales.salesperson. So in the Object Explorer pane, browse the first required table, sales.salesperson. Expand the databases folder, expand the target database, and expand tables folder. Here you can find the table sales.salesperson. Right-click on the table and choose Edit Top 200 Rows. This is the first 200 rows of the table in an edit grid. Don't worry, you cannot edit data because you got a read-only access to this database. You can edit values in the grid, but it is not saved until you step out from the row. If you try to step out, for example, by a down arrow key, then you get this error message. Okay, so while this table is opened, a new Query Designer toolset is displayed on the toolbar. Here you can find some controls for different panes, which I call simply windows. Turn on Diagram window, Criteria window, SQL window, and the result window is already there. A couple words about these windows. You cannot change the order of these windows, so Diagram window is always on the top and the result window is always on the bottom. Diagram window shows tables used in this query and the relation between them. The criteria window shows the selected columns of the tables of the diagram window, and you can set here different calculations. Each row of this window represents a column used in the report a result or for filtering. You can define an alias name for each column. You can set ordering precedence and ordering directions. And you can set here filter conditions or criterias. You will see how it works in next sections of this course. Let's turn off SQL windows now because we don't use SQL coding. Let's see the diagram window first. Here tables are represented as boxes and columns of the tables are listed. You can simply move and resize these boxes to achieve the best arrangement. By these checkboxes, you can control which columns are displayed in the result of the query. If you want to add or remove more columns, then select them by holding down the Ctrl or Shift key and click on Items. After you select multiple columns, click on the checkbox of any selected item. You can see that changes in the query is not immediately reflected in the result window. This avoids unnecessary overhead of the database server. So I removed columns, but the result is still there with all columns. If you want to refresh result and see what you changed in the query, just click on Execute SQL button on the toolbar. As you can see, some columns are bolded. That column is the primary key of the table. This table does not contain the name of the salesperson, so we need the person table. To add table to our query, just click on Add Table icon on the toolbar. Here you can select the person table and press Add, then Close. You can see that Query Designer automatically connected these two tables by columns Business Entity ID, which is fine now. But this is not because the name of columns are the same in two tables. It's just a chance. This is because the relationship is defined in the background by database developers. But if developers forgot to define these connections, then you have to define it manually. Let's see how. If you don't agree with this connection, you can remove it anytime. Just right-click on the line and choose Remove, and then it removed. To define a connection between two tables, select the column in first table and drag and drop it to the proper column in the box of the second table. Okay, based on the definition of the report, we need the full name of the salesperson. This connection between tables in a query called join in database terminology. So SQL Server search for each line in both tables and tries to find rows which are matched by the column pair what we connected to each other. So if we have a specific value in a row in salesperson table in column business entity ID, and we have the same value in any row of person table in column business entity ID, then the result will show the row from both tables. To be more specific, a result will show the rows with selected columns from both tables. So we need the first name and last name of the person from person table, but nothing else. Remember, This is needed because name of the salesperson is not in salesperson table. Now we have a complete query. Let's see how the result is look like. So click on Execute SQL button on the toolbar. In the result window, you can see the tabular result of our query. And one more important thing, the total number of rows of the result can be seen here. We have 17 salespersons. To construct the full name, we have to use a formula. To do this, we use the criteria window in the middle of the screen. The formula is the following. First name plus a space between apostrophes plus last name, enter. Query Designer automatically extended and completed our expression by correct table and column names. This will be a new column in our query, so we have to add an alias name in the alias area of this window. Full name. Let's test the query again by clicking on Execute SQL button on the toolbar. This looks good, but we don't need the individual first name and last name columns, so we can remove them. Rerun the query again. Okay, next step is to add sales data. So we need sales order header. Let's add it to our query and move boxes to see the most important things. The Query Designer automatically joins salesperson and sales order header by business entity ID and salesperson ID, which is fine for us. The report definition mentions that we have to work with sales only in 2011 based on order date. So let's add this criteria the following way. Select the order date column in diagram window and add the criteria in criteria window. The criteria is the following. Between apostrophe 1st of January of 2011 apostrophe and apostrophe 31 of December of 2011 apostrophe enter. Query Designer changes date format to the local regional settings, so that's fine. If you test this query, you will experience that the result is multiplicated. This is normal because a salesperson can have multiple orders sold even on the same day. Moreover, we don't want to display the order date itself. Just use it for filtering. In this case, you cannot remove the column by clicking on the checkbox in the diagram window. In this case, we need to click on the Output checkbox in Criteria window. Okay. So, to have correct calculation, we need to group this query by salesperson and aggregate the sales. So, let's convert this query to an aggregation query by clicking on the Add Group By button on the toolbar. After this action, the criteria window is extended by a new Group By column. This defines the role of each expression in the aggregated query. For example, Group By is for defining groups, Where is to define filters on rows before we group and aggregate them. Let's add a new expression in the new column by running a count on the rows. For the expression, select or type count star into the column part. The alias can be orders. Test the query. Good. So what is this result about? It shows how many orders were sold by each salesperson in 2011. But look, now we have only 10 salesperson. Remember, we had 17 before. This is because not all salesperson have any order in 2011. That is a problem, because the report description says that we have to display a salesperson anyway, even he has no sold order at all. To solve this problem, we have to create a prepared result which is already filtered and aggregated. This solution called subquery. The subquery filters and aggregates sales data and group it by salesperson ID to be able to attach this query. Let's see this in the next section. A subquery is a query which can be constructed the same way as normal query and shown before. So let's construct that subquery. To do that, start from sales order header. Open it in Query Designer. Unfortunately, there is no possibility to open a new empty Query Designer in SQL Server Management Studio. You always have to open a selected table to have a new Query Designer window. Now let's open Sales Order Header. You can see that the result contains only 200 rows. But we know that the Sales Order Header table must contain more than 200 rows. This is because the result is limited by default in this Query Designer, but we don't want a limit. So to remove limit, right-click in diagram window on an empty space, and in the menu choose Properties. Here are the properties of this query. Here you can find a top specification and set it to no. If you run the query again, you will get more results, but if you don't want to wait until all rows are downloaded, then just click on the stop button in the result window here. This interrupts the query execution. Now the counter shows only the downloaded number of rows, but there can be more rows if we would not interrupt the execution. Remove columns, what we don't need. Add salesperson ID or keep salesperson ID. Add filter on order date. Now I copy that from main query. You can switch anytime between different instances of Query Designer. Okay, now add table sales order detail because we need the line total. Sales order detail and sales order header are joined by sales order ID. That is fine. Add line total to the output. Let's add group by. We need to group by salesperson ID, but we don't want to group by and display order date. So it is only a where. And finally, calculate a summary of line total. This way. Alias can be total sales. Let's run the query. This is the result what we need. 11 rows, because only these salespersons have sold orders in 2011. You can see that there is one row where salesperson ID column have a null label. A null is not a value. It is an indicator of missing data. What does this mean? It means that sometimes salesperson ID column in sales order header does not contain a valid value. Sometimes this column is empty. In databases, the null is empty. The null means that the cell is empty. Group by functionality of SQL Server created a separate group for those nulls. So we have 10 valid salesperson ID. There are in 10 groups, and one more additional group for nulls. So finally we have 11 groups in 11 rows in the result. Let's put this query as a subquery into our main query. Switch back to the main query. Remove sales order header table by right-click on it and choose Remove. This action removes the filter criteria on order date related to that table. Remove Group By from the main query. Now let's add the subquery. Click on Add New Derived Table button on the toolbar. Then a new box is displayed in the diagram window. This represents a subquery with an alias name derived table _1. Now turn on the SQL window. This is the only one step to do in SQL, but you still don't have to understand SQL language. In the SQL code text, find the empty subquery part. This is easy because it contains a select from expression in brackets, and after that as and the subquery alias, as I mentioned. Select everything in brackets and delete it. The result is an empty brackets pair. Now switch back to subquery window and copy everything from the SQL window. You don't have to understand the SQL code, you just need to copy it into the clipboard. Switch back to the main query window and paste the copied SQL code into the empty brackets. Finally, click on Verify SQL Syntax button on the toolbar. Okay, now you can see that the query designer understands the SQL code and the result is displayed as a table. The output columns of the subquery are displayed as columns of a table. The alias name of this subquery can be changed anytime. Just right-click on the title bar of the subquery in the diagram window and choose Properties. In the Properties window, you can edit the alias name of the subquery. Let's give all sales. Enter. Query Designer doesn't know the relation between existing tables and our subquery, so we have to define it. As we saw before, we can simply connect two tables by drag and drop columns. So now I drag salesperson ID of all sales to business entity ID of salesperson. That's it. This line represents the join connection between the tables, and we want to display only total sales from this subquery. Okay, execute this query. We have the full name and total sales in 2011. But wait, we have two problems. First, we still have only 10 rows. However, we saw that subquery returned 11 rows. This is because 10 rows had a valid salesperson ID, but one row contains null. Because null is not a valid value, it cannot be matched any of the salesperson IDs from the salesperson. The second problem is that we still have only 10 rows, but remember we had 17 salespersons. This is because the join between salesperson and all sales is an inner join. This type of join shows only matching rows, and remember the subquery returned only 10 valid rows and a piece of null. This is why we have only 10 rows in the final result. To display all 17 salespersons, but having only 10 matching rows from all sales, we have to change the join type between them. Right-click on the line between them and choose item Select all rows from salesperson. The box on the line has changed. Now it is a left join. It will return everything from salesperson and matching rows from the all sales query. Let's run the query again. Now we have 17 lines of the 17 salespersons, but some of them have no value in total sales column. In this case, a null is displayed. Null is not a value, it is only an indicator of a missing data. But there is a function which can replace missing data to a default value. Use this function to replace nulls to a zero value. Type this expression in criteria window. Is null, this is the name of the function, open bracket, all sales dot total sales, comma, 0, closing brackets, enter, and give an alias name called total sales. So the isNull function has two parameters, and it returns the first parameter, but if that is null, then returns the second parameter. This way, now it replaces nulls to zeros. Okay. We have another requirement in the report description, so get total sales value of the specific product. Products which name starts with HL mountain frame. To achieve this, go back to Query Designer of the subquery and extend that query. Let's add the product table. We have to connect sales order detail to product by product ID. Now the Query Designer joins them automatically. That is correct. Now select the name of the product in diagram window. Then add the filter criteria in criteria window. The criteria is name, like apostrophe, HL mountain frame, a %, closing apostrophe, enter. So here is another element, the like operator. A like operator can search for patterns. In this case, the name of the product must start with the given text and can be ended by anything. Just for testing, temporarily add the name of product to the output of the query and run it. You can see that there are some products starting by HL mountain frame. Okay, it works. Now remove this name column. You can test the query again and check the result. So let's put this query into the main query as a second subquery. A query can contain any subqueries. Now we already know the method how to do that. Copy the SQL code of the query and switch back to main query. Add the subquery by this button on the toolbar. Find subquery placeholder in SQL code. Insert the subquery code from clipboard. Check the syntax. Select the subquery box in diagram window and open properties. Change the alias name of the subquery to product sales. Select total sales column to the output and give an alias name to it, product sales. Test the query results. Okay. Here we can do the same null replacement as we did it in the case of total sales. Okay, run it again. Then only one step left. Calculating the ratio. The formula is product sales divided by total sales. However, there are some zero values in total sales. This would lead to division by zero error. Here, null values can save us because division by null is different than division by zero. A division by null results a null and not an error. Okay, let's test the query. Almost perfect. Let's replace nulls to zeros. Okay. Final test. And we are done. You can use this method to prepare a report, and you can check real data in database. If you are satisfied with the result, then you can turn on the SQL windows and copy the query text into the specification document. If you show this query code for a report developer or a database developer, then he or she will understand it better than any other text description. This was the basic usage of the built-in query designer of SQL Server Management Studio. What is the benefit of this compared to other query tools like Microsoft Access, Power Query, or ClickView? The benefit is that here the query is completely run on server side. Only the result is downloaded. You don't need to download thousands or millions of rows over the network and overload your computer. Everything works on the SQL Server side. Okay, what could be the next steps after that? For example, give alias name of columns to have the same column headers as defined in the specification. Or try different ordering settings of the final result. Or change order of columns or column expression in result. Try to drag and drop row header buttons of expression lines in criteria window. Try to copy the SQL text of this query into a notepad. Then close the query designer and open a new one on another table. Then override the initial SQL query by that one in the notepad. Finally, try to create a subquery from this query in a new Query Designer window. Have a good job!